Now we're asked to find the equation of a tangent plane to this surface at a point. And the way to think about it is to think in terms of level surfaces in this case, right? So if you think of the function f of x, y, z equal to the sine of x, y, z, that is a function that goes from the 3D space into R to the real line. And what does that mean? Well, every level surface, which is a surface in here that has constant f value, so on this red surface I just drew, I'm assuming all the function value is constant along the surface. All these points have the same function value. Let's say some value there. What does that mean? Well, for the function to change, I need to leave the surface because the entire surface has constant value. So that means theoretically that the gradient of the function has to point as far away from the surface as possible, because the gradient is supposed to be the fastest direction of change, and for you to change you have to leave the function. So the fastest you leave the surface, the faster you change the function value. So basically I'm saying that the normal vector to the surface at any point is the gradient of the function f. So that's what we'll calculate. Gradient of f is df dx, comma, df dy, df dz. So that is the vector we're calculating. The first derivative is pretty simple. We use the chain rule. So derivative of sine is cosine of the angle times the derivative of the inside by the chain rule. So that is with respect to x. So the derivative is yz. And then repeat the process 2 more times. So it's the cosine of x, yz times, now with respect to y, the result is xz, comma, the third coordinate will be the cosine of xyz, comma, not comma, times derivative of the inside with respect to z, which is xy. So we want to know the coordinates of this tangent plane at the point pi 1 1/4. So the gradient of f at pi 1 1/4 is plugging these values in. This is x, this is y, this is z. We'll get, so the first coordinate is the cosine of pi times 1 times 1/4, so pi over 4th, times yz, so 1/4. The second coordinate, it's the same angle, same cosine, times xz, so pi times 1/4, pi over 4, and then same cosine pi over 4 times xy, so pi. If you remember that the cosine of pi over 4 is the cosine of 45 degrees, which is square root of 2 over 2. Take care of this 1/4 there, square root of 2 over 2 times 1/4, square root of 2 over 8, comma, pi root 2 over 8, comma, pi root 2 over 2. So this is the gradient of f at the point which is normal to my surface, and by that I know that the tangent plane to the surface at that point is also normal to that gradient. So that's the drawing, that's the plane I'm looking for. It's a plane that goes through this point that has this normal vector. So it will be root 2 over 8. That's the a of the plane, x minus pi, plus pi root 2 over 8 y minus 1 plus pi root 2 over 2, that's a pi right there, z minus 1/4 equal to 0. That's the equation of a plane. These are the coordinates of a point that's contained in the plane, and these are the coefficients, which are the coordinates of the normal vector. You can expand on that to get a better result. Maybe multiply both sides by 8 would be a good idea to get rid of this 8 and this 8 and this 2. Maybe that'd be good. I think it'd be a good idea. Up to you to simplify the rest.